right, so let's tackle that number 9. It seems that most of you, just kind of looking through the Chapter 2 review from what you guys have turned in, I think most of you are getting scientific notation. If you're still having trouble with scientific notation, I'm going to touch on that a little bit as we're going through these videos for number 9, but there's quite a few problems here, so I'm going to try to move through them quickly so that you're not sitting here watching a video all day, and so that I'm not doing it all day. So let's take a look at number 9, and you turned in your paper, so you're not going to probably see what I'm seeing. So I will post a copy of this on Blackboard, a copy of page 9, this review, so you can kind of see it again and practice it. So number 9 basically is made up of, let's see how many problems we have here. 1, 2, 3, 4, 5, 6, 7, 8. There's 16 problems in number 9. So I'm just going to do them as if they're 16 problems individually. So let's go. So for the first one, 7.03 centimeters to nanometers. All right, so remember, we have 2 base units here. We have 1 base unit and 2 prefixes. So let's look at our base unit. Our base unit here is meters, right? Oh, I decided to do 1 in red and 1 in black. Here's our base unit. And then this is our prefix. So our prefix is here in centimeters to nanometers. Now, if you recall the table, the table is meant to give you the relationship between the prefix and the base unit, not information between base units. Not between prefixes and prefixes. So I do not know the relationship between centimeters and nanometers. I do, however, know the relationship between centimeters and meters. So that's what I'm going to use. So what I would recommend doing is breaking this into 2 parts. Setting up a problem and saying 7.03 centimeters and going to this base unit right here of meters, right? Get an answer from this. So let's do this first. 7.03 centimeters. If I want to go to meters, that has to be left on top. Remember math. Remember your basic math, okay? If you want to cancel something out, like if I want to cancel out this unit here, I have to put it on the bottom. Sorry, you're hearing my son sing in the background. Let's see here. So we're going to cancel out centimeters and centimeters, and that leaves you with meters. So here we need a relationship between meters and centimeters. So go back to the video that I just posted, the one before this, and decide what works for you. Again, I prefer the red way that I was doing earlier, so I would say 100 centimeters is equal to 1 meter. Or if you think about the blue way that we discussed, 10 to the negative 2 meters is equal to 1 centimeter. Whichever way you prefer is how you should continue with this problem. It really is up to you. Again, I'm going to continue with the red because I think that's just my preference. So I'm going to say, again, 1 meter, and again, 1 here, and then it's 100 centimeters. So I'm going to basically do 7.03 times 1 divided by 100. And to make sure I don't give you guys any funny math, I'm actually going to use my calculator just to double check everything I do. And that is going to give you 0.0703 meters. All right, so this is a good start because our final answer needs to be in nanometers. So what we'll do from here, so we kind of split this up. So this was the first step. We want to now get this meter answer into nanometers. So I'm going to go 0.0703 meters, and I want to convert that to nanometers. All right? So 0.0703 meters. do my little table here. Meters is on the bottom. My final answer needs to be in nanometers. Meters going to go on the bottom, nanometers on top. All right, meters and meters cancel, leaving me the unit of nanometer. Now, let's go back to what I was saying. Let's get these relationships down. Nano is 9, okay? Nano 9. So I could say there's 10 to the 9th nanometers in 1 meter, or if you want to physically interpret from that table, 10 to the negative 9 meters in 1 nanometer. Okay, got it? So I'm going to do the red way, or just to keep it consistent here. There's going to be 10 to the 9th nanometers in 1 meter. All right, so you're going to do 0.0703 times 10 to the 9th in your calculator. So times 10 to the 9th, and let's put that in. The answer that you get back is it's a large number, so I'm going to go ahead and put that in sign. Actually, here's some time to practice. Let's see, hopefully I can fit it here. It's 703, and then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. Ooh. Okay, let's go ahead and practice our scientific notation. So 703, 1, 2, 3, 4, 5. So your decimal points here. We're going to practice our scientific notation. We're going to go 1, 2, 3, 4, 5, 6, 7. So the answer is going to be 7.03 times 10 to the 7th nanometers. All right, do not forget that nanometers. There you go. So that is the first question there for number 9. So number 9, question 1. All right, so let's take a second and get this cleaned up, and we'll go on to the next one. All right, so the next question here is going to be, I'm going to move across the page, so it's going to be (3.3) times 10 to the positive 5 grams is equal to, and then they put blank kilograms. All right, so let's take a look. First, we have to look at the relationship between gram and kilogram. All right, so you could say, let's look at the red number. Let's do a red way. There is, oh, we need to make that a little darker. For every, there are 1,000 grams in 1 kilogram, right? And then I think that's really the, there isn't really a blue way to write this one. I guess you could say 10 to the 3 grams is equal to 1 kilogram. You could say negative, but that would be confusing. There really isn't a distinction between red and blue in this particular situation, because kilo is to the 3rd power. So it's not, there's no negative here, so there's really no other way to write it. So this one's pretty straightforward interpretation of the table. So let's write that one down. 3.3 times 10 to the 5th grams. Grams is going to go on the bottom, kilograms are on the top. again, just make your table and instantly write in the units, okay? Again, maybe I should go through, and I said before, we have kilo, you have base unit, and deci, centi, milli, micro, and nano, and we said 10 to the 3, and I said, so this will be in red, 10, oh, not 10 to the 2. That's not right. Ten to the 1, 10 to the 2, 10 to the 3, 10 to the 6, 10 to the 9. And again, this would be, as I was saying before, the red way. Without using negative prefixes. If you want it to be the blue way, notice kilogram, the kilo doesn't change, but you would just go in and add negatives here. Like that. So I'm going to add that in. So let's take a look. So if we're looking here at this, remember size increases as you go up this table, right? So 1 goes next to the larger one, and then kilo is 1,000, so we say 1,000, right? So we do this number times 1,000. Now here's where I think technically it's probably easier to use scientific notation. So that's what we're going to use. I'm going to erase this, give us a little scientific notation practice. 10 to the 3rd. So remember the rules. If you're dividing, because that's what we're doing here, you subtract the exponents. So you would have 3.3 times 10 to the 5th minus 3. So that's 3.3 times 10. 5 minus 3 is 2, and then the final unit is kilograms because grams and grams cancel. Remember, when you're dividing exponents, you subtract them. Okay, that's where I got this answer. Or you can completely ignore the scientific notation and just plug this into your calculator. You would say 3.3 times 10 to the 5th divided by 1,000. But notice I didn't have to use a calculator here. I just did that math and got this answer. So that is that problem. All right, let's take a look at the next one. All right, so continuing with number 9, we are going to look at the next one, and this one is a little different than the previous 2 problems in number 9. This will not use any of the standard metrics prefixes. It's going to use another conversion factor. And let's take a look. So we have 88 miles per hour, and they want to know how many kilometers per hour. All right, so we have, and let's go ahead and write it out, 88 miles per hour, and we want to convert that to kilometers per hour. Now notice that hour is on the bottom already, so completely leave it alone. You don't have to do anything with it. But we do need to go from miles to kilometers. So we need to go from miles to kilometers. So we need a conversion factor. So if you look in your lab manual on page 26, there is the conversion factor there, and I would give you this on an exam. 1 mile is equal to 1.6 kilometers. All right, so what we'll do here, just like we did before, if we want miles to cancel out, we put it on the bottom. Miles, or technically that should be mile, because we are just going to have one of them. For every 1 mile, there is 1.6 kilometers. So now we just miles and miles cancel out. Now notice we're left with kilometers over hours. Okay, we don't really have to do anything with that. 88 times 1.6, and that is left with 140.8 kilometers per hour. All right, what we just did here is called dimensional analysis. You have to understand how to set these problems up. This is why I deter you from using the moving the decimal place. This is a common way you would apply these. This right here is called a conversion factor. And the conversion factor because you're converting from one unit to another one. And that's essentially what we're doing when we go from milligrams to grams. You're converting from one unit to another unit. So again, hopefully that helps with this one. So let's take a look at the next one. And again, I'm going to go across from there, and I've lost my page. Here it is. So let's clear this off. And this next one is, oh, I need a pen. Here we go. It is 8.33 times 10 to the negative 3 milliliters. Oh, and they want you to put it in gallons. All right, so let's go again to that table on page 26. Let's find volume. And it tells me that I'm trying to find a relationship between the metric unit and then our standard unit here. I do see this one. Let's get another color here. Let's go with my color wheel. I want to get a color that I haven't used yet, so I don't want to confuse you. What we want here is, if we're looking at page 26 here, it is, I see when I'm looking for something that has gallons in it, and on page 26, I do see for every 1 gallon, I need 3.79 liters. So here's where you have to stop. You're like, well, this guy here is in milliliters. You have to make a plan. If I can convert this guy from milliliters to liters, and then I'll have something to go on. So that's what I'm going to do. So here's the start of my plan. I'm going to go from 8.33 times 10 to the minus 3 milliliters, and I'm going to convert that to liters. Milliliters is going to go in the bottom, liters is going to go on the top. I know that for every 1 liter, I have 1,000 milliliters. So, or for those of you who like using the negative, you could say 10 to the minus 3 liters in 1 milliliter. Whatever floats your boat here. Doesn't matter, they mean exactly the same thing. So I think I like again, 1 next to the larger unit. I know that their liter is much larger than a milliliter. So 1, and then I'm going to put 1,000 down here. Then put this in your calculator. 8.33 times 10 to the negative 3 times 1 divided by 1,000, and you should get 8.33, but I'm just going to double check and make sure that I'm not losing my mind. And, oh wait, you're right. No, I am. I did not do proper math. 8.33. You really didn't need a calculator for this one, because you could have said, let's look at this. Remember, we're supposed to be learning our scientific notation here to make our math easier. Let's go back for a second and take a look at this. If I put 10 to the 3 here, remember when you remember division, when you're dividing, if you want to use scientific notation, you have to subtract the exponents. So 10 minus 3 and then minus 3 gives us a negative 6, which is what we have here. Okay, and so that unit should be liters. So liters, okay? Now, that isn't what our answer is supposed to be. That's not our final answer. So let's go ahead and clean this up a little bit and get our final answer. So we have, let's just clear this up. And let's delete this as well. And this. So we're going to take that liter value there. Now we can turn around and use this gallons because we now have our answer in the form of a liter. Let's try to make it look, give me a little bit of space down here. All right, so now we have our answer in liters. We can use this conversion factor here. So I'm going to go ahead and put that in purple. And I've lost my purple again. Let's come up here to this purple. All right, so we're going to start with 8.33 times 10 to the negative 6 liters. Just like we always do, we're going to do our train tracks here. And we want our final answer in gallons, so we need to put liters on the bottom because we want that to cancel. And then I'm just going to put GAL on the top for gallon. I know that for every 3.79 liters, there's 1 gallon. So I'm going to take that 8.33 times 10 to the negative 6, and I'm going to divide it by 3.79. And I have gotten, and because we started out up here with 3 numbers, I'm going to put my final answer in 3 numbers, and it's going to be I'm just going to round a little bit here, times 10 to the negative 6 gallons. You get, if you put this in your calculator should spit back to you 2.197889182, and we don't need to write all those numbers down. I just made it, I rounded it to 2.20. You could have very well put 2.2 if you wanted to, or if you wanted to write 2.19788, if you want to write all the numbers down, you're welcome to. It's really up to you. But there's the answer. All right, so let's take a look at another video, another problem. All right, let's clear this up. Let's look at the next one. The next problem. Okay, here's another prefix problem. So let's get some practice with that. And this one's one of the ones that's going to have multiple steps. So it is 88 micrometers, and they want you to turn that into millimeters, okay? All right, so from here, again, let's break this problem down. Here are here's your base unit, all right? Base unit and base unit, all right? This is a prefix, and this is a prefix. So my base unit here is meters, all right? Our table is not going to tell us the relationship between micrometers and millimeters. It's going to tell us the relationship between micrometers and meters and millimeters and meters. So this is a 2-step problem. We need to first convert to our base unit. So what we need to do is we need to go micrometers to meters. We got to get it in that base unit. And then once we get that, we can go meters to millimeters. All right. You could do this as one problem if you wanted to. I was doing that in class. to meters to millimeters. That's a one step if you do it like that. I'm going to break it up into two steps just to make sure everybody understands. So we're going to go 88 micrometers, and I'm going to first convert that to meters. Put meters on the top. Micrometers is going to go on the bottom because we need that to cancel out. Here I need a relationship between micrometers and meters. Again, you could say that there's 10 to the 6 micrometers in 1 meter, or you could say there's 10 to the minus 6 meters in 1 micrometer. It's really up to you. Just make sure you keep it consistent. I'm going to put 1 and then 10 to the 6th here. All right. You should get 88 times 10 to the negative 6 meters if you plug that in. Take a second and look at this. If I were to, you're going to get the same, this is not proper scientific notation, but I'm going to leave it like this because this isn't our final answer and it's easier, so I didn't have to use the calculator. Now let's take it to the next step. We've got our answer in meters, so we've done that. Now we need to go from meters to millimeters. So we're going to go 88 times 10 to the, I'm all over the place here. Let's erase that. 6 meters, and I'm going to convert that to millimeters. Meters is going to go on the bottom, millimeters is on the top. Remember, stuff that's on the bottom, like over here, this one's on the top, and there's one on the bottom, so it cancels, and that leaves us with a unit of meters. Over here, same thing. Meters is on the top and meters on the bottom. We cancel that out, okay? And it leaves you with a unit of millimeters. We need to look at the relationship between meter and millimeter. So I know for that there's 10 to the 3rd millimeters in 1 meter, or if you want to, you could say there is 10 to the negative 3 meters in 1 millimeter. It's up to you, whatever you want. I'm going to use the red one. 1 goes next to this larger, and then you have 10 to the 3rd. So I'm just going to add across here the exponents. Remember, when you're multiplying, you add exponents. So 88 times 10 to the negative 6 times 10 to the 3rd. You can just plug this into your calculator, but you will get 88 times 10 to the minus 3 millimeters. We cannot leave that answer, so we need to clean that up some. So we're going to say, oh, I need my pen back. We need 88 times 10 to the negative 3 millimeters. We have, remember, 1 line leader, so it needs to go this way 1. So we're going to add 1 here. 88.8 times 10 to the minus 2 millimeters. Plug it into your calculator and check it as well. So that's what I'm about to do, just to double check your math. All right, 88 times 10 to the negative 6 times 10 to the 3rd, and gives me, if you plug this in your calculator, just to kind of clarify, I'm going to write it in purple. Where's my purple? There it is. If you put 88 times 10 to the negative 6 times 10 to the power 3rd, it's going to go ahead and shoot back to you 0.88. You're welcome to just leave that in millimeters. I can't get my millimeter in there. Or this is the same thing, 8.8. If you're questioning whether your answer is right, put it in the calculator and see what it gets. So if I put 8.8 times 10 to the minus 2 in the calculator and just hit enter, it does give me back 0.088 millimeters. So either of these answers is correct. They're the same thing. All right. That does say millimeters. I just really kind of squished it in there. So there's that one. Let's take a look at the next one. All right, the next one is temperature problem. So let's take a look at that one. And let me get my ink. Here we go. So we have, it says convert 4 degrees Celsius to degrees Fahrenheit. All right, so here you need to refer to page 26 and get the formula. So we're going to use the formula that looks like this. It is degrees Fahrenheit is equal to degrees Celsius times 9/5 plus 32, okay? So let's plug it in. What you want to do is use this formula here. So that's the formula. So we're going to say degrees Fahrenheit is equal, and we're just going to plug in 4 degrees, 4 times 9/5 plus 32. Here you have to think about order of operations, so that please excuse my dear Aunt Sally Pimdos. You need to do the multiplication before addition. All right, so we're going to do in your calculator. Now, you could just plug this right into your calculator. Your calculator does it automatically, but I'm going to break it down for you just to show you how to get the math. So 4 times 9/5, and that is 7.2 plus 30. Oh, I wrote 35 here. That should say 32. That should say 32. Let me get my pen back. Come on. There we go. No. Cancel. 32. Good thing I called that, or we'd had some wrong answers. All right, so now we want to do 7.2 plus 32. 7.2 plus 32. And you get 39.2. Again, and that's degrees Fahrenheit. And I'm just going to plug it all in one more time just to double check my answers. And I'm good to go. So 4 degrees Celsius is equal to 39.2 degrees Fahrenheit. I would give you this equation here so you don't have to memorize it. All right, so there's that one. What's my next? And I dropped my mouse, so that's why you have a random pop up there. All right, let's take a look at another one. The next one here says 16 miles is equal to how many, let me keep my format. They want you to convert 16 miles to millimeters. Okay, so 16 miles to millimeters. Now here is where you're going to, again, you're going to want to look at page 26 in your book to get the conversion, and I'm going to go there now. We want to look and find a relationship between miles and millimeters. So we did find something earlier. We used, remember we used for every 1 mile, there is 1.6 kilometers. So it doesn't quite get us to millimeters, but it does get us to kilometers. So this one is probably the toughest one that we've looked at so far, only because it's going to take us a while to get to the answer. So we need a really good plan. So let's plan it. First, let's plan what we're going to do. I would say, let's go from miles to kilometers using this guy right here, okay? Once we get kilometers, we can convert kilometers to meters, right? Because we need to convert it to the base unit. And then once we have meters, we can convert that to millimeters. That's our plan, all right? So it's 3-step problem. 1, 2, and then 3. Got it? So again, base unit, and then here, and then we can add in that prefix there. So let's take a look. So step 1, we're going to go 16 miles. And then again, if you want to pause it and do this, pause it, and then come back and see what I've done. That may be helpful. So for every 1 mile, I'm going to put this, there's 1.6 kilometers. Miles and miles cancels and leaves you with that unit of kilometers. So we're going to say 16 times 1.6, and that should give you 25.6 kilometers. All right, 25.6 kilometers. That's problem 1. Now I'm going to squeeze part 2 up here. So we're going to go to 5.6 kilometers. And so we've done this one, we're done. We're going to go kilometers to meters. So kilometers is going to go on the bottom, meters is going to go on the top. Here, what's larger, the kilometer or the meter? We got to look at our conversions. For every 1 kilometer, there is 1,000 meters. Okay? So for every 1 kilometer, there's 1,000 meters. So the answer for this one, and I'm going to have to squeeze it in down here, 25.6 times 1,000, 25,600 meters. 25,600 meters. Now I'm going to squeeze part 3. Let's try to just see if we can move this over. I'm just going to delete this part here. We're going to go here and we'll say part 3, 25,600 meters. And so we've done that. We went kilometers to meters. So kilometers cancels out kilometers, leaving you with the unit of meters. Now we're going to go from meters to millimeters. All right, meters goes on the bottom, millimeters on top. All right, let's take a look at our conversions real quick. We could say that there are 1,000 millimeters in 1 meter, or if you want to go directly from that table and use your negative values, 10 to the negative 3 meters is equal to 1 millimeter. Really is up to you. I'm going to use the red. So 1 meter is the largest, so 1's going to go here, and then 1,000. If you were using the blue, you would put 10 to the negative 3 on the bottom, and then 1 on the top. It's still going to give you the same answer. 25,600 times 1,000. And that gives you a huge number, which gives us a chance to practice our scientific notation. 6, and then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, let's put this, and then that's millimeters. Let's put this in scientific notation. We're going to say 1, 2, 3, 4, 5, 6, 7. 2.56 times 10 to the 7th millimeters. And there you have it. There's our final answer. So that one was a lot, but again, notice I had a plan. Don't just jump into some of these, especially when you're not given. I'm sure, and as well, you probably could Google a conversion, and it gives you some flat number between miles and millimeters, or some value, but it's best to have some sort of plan and go with it that way. You can't ever go wrong. All right, let's clear this up, and we're going to go to the next one. All right, the next problem is going from grams to pounds. So this is going to be another one that we're going to have to refer to page 26. So this one is 2.6 grams. It's make that look. And they want you to go to pounds. All right, so we're going to look at page 26 and see what we can find. I'm going to change the purple. So I'm trying to get in the habit of every time that we're using page 26, I use purple so that it can stay consistent, do the same things over and over again. 26, let's take a look. Page 26, we want to find a relationship between grams and pounds. So we're looking at mass. Here we go. I see that for every 1 pound, it's 4, 5, 6 grams. Oh, where did I get that 6 from? That's not right. Back up. For every 1, 4, 5, 4, not 6 here. 4, 5, 4 grams. All right, so we're going to go ahead with this. Again, I would give you this on an exam. We're going to go 2.6 grams. We're going to cancel out grams, so we want to put that on the bottom, and then we want pounds on the top. For every 1 pound, there's 454 grams. So what we're going to do basically here, if you're plugging this into your calculator, 2.6 times 1 divided by 454. So 2.6 divided by 454, oh, that's tiny. 0, 0, 5, 7, 2, 6. So I'm just going to kind of write it only because I have space. Here's my number, 572 68722. I probably would round this to about here. So you could say 0057. If you want, oh, I'm missing pound here. Pounds. Actually, pound. If you want to use scientific notation, you would go 1, 2, 3. Actually, what am I doing? I'm going too far. Now, why my brain wanted to keep going. So we're going to go 1, 2, 3. So 5.7 times 10 to the minus 3 pound. Tiny, tiny, tiny. And there's that answer, but you don't have to. You could just leave it like that if you want. All right, on to the next one. All right, next problem is .7 milligrams to kilograms. All right, again, at this point, this is probably the second or third one that we've done like this. I want you to pause the video and work through this one yourself. Once you feel like you've gotten it, restart it up, and I'm going to explain again how to do it just in case you had questions, but I do encourage you to pause it now and try this problem on your own. All right, so again, when you're looking at this problem, this is going to be a two-step problem. Here's your base unit of grams, and then you have two prefixes, milli and kilo. All right, so our plan, what I would do here is go from milligrams to grams, because grams is that base unit. That will be my first step. And then my second step would be to go from grams to kilograms. All right. If you want to treat this in one whole problem, just go milligrams to grams to kilograms, like that. Okay, it's really up to you. But it's the same problem. So 2 steps, and this one's also 2 steps. It's just written out as one. So let's look at the first one. So we're going to say 1.7 milligrams to your crisscross. Milligrams is going to go on the bottom, grams is on the top. And here's where you're going to get your prefixes. I'll use the table. Again, just like I've done, you're either going to say 1,000 milligrams in 1 gram, or you can say there's 10 to the negative third grams in 1 milligram. Up to you. I'm going to say for every 1 gram, there's 1,000 milligrams. And that answer will be 1.7 times 10 to the minus third grams. Okay? So do 1.7 divided by 1,000. It's probably not going to shoot back to you scientific notation. I just did that quickly in my head. I'm going to give you back this. This is what it's going to give you if you put it in your calculator. It's going to tell you 0.0017 grams. These are the same answer. This one was just allow me to do the math without using a calculator. This is what my calculator is going to give me. So 1.7 times 10 to the minus 3 grams. Up here, remember, milligrams and milligrams cancels, leaving you with a unit of grams. And then here we're going to go from grams to kilograms. So grams is going to go on the bottom, kilograms on the top. Again, let's look at using for every 1 kilogram, there's 1,000 grams. So for every, so there's 1,000, I was about to write it wrong. There's 1,000 grams in 1 kilogram. So that's going to be 1.7 times 10 to the minus 6 kilograms. And if you want to plug that into your calculator, 1.7 times 10 to the negative 3 divided by 1,000. And that is 1.7 times 10 to the minus 6. I don't know if you can see what the scribble, again, here it is. I don't think I made that look any better. Let's clean this up. Let me give you this again. I don't think you can read any of what I've typed out here or written out. So here it is equal to 1.7 times 10 to the minus 6 kilograms. And there's your answer. So hopefully that's what you did as well when you did the problem on your own. All right, on to the next one. The next problem is oh, I don't have color. Let's get some color on this. What do we have? 3.62 times 10 to the minus 4 liters. And we're going to milliliters. Again, please pause the video and do this one on your own and then come back. So if we're looking here at this, we could say that there are 1,000 milliliters in 1 liter, or you could say there is 10 to the minus 3 liters in 1 milliliter. Up to you completely. 3.62 times 10 to the minus 4 liters. Remember, liters is going to go on the bottom, milliliters are on the top. 1 goes next to your largest unit, and then milli is 10 to the third, or 1,000. Actually, I'm going to do 1/3 10 to the power 3 because that math is easier. And we can practice our exponents. So let's do 10 to the third. Remember, we add exponents here because we're multiplying. So you have 3.62, a negative 4 plus 3 is equal to a negative 1. So you have 10 to the negative 1 milliliters. If you do not care for doing this, just say 3.62 times 10 to the power of negative 4 times 1,000, and that's going to give you your answer. And also, just to make sure everything's clear, 10 to the third milliliters is equal to 1 liter. That's what I've written here. These two are the same. Same. All right. So let's clear that up. All right. Next problem. On the previous one, we had 3.62 times 10 to the minus 1 milliliters. You probably put this into your calculator and you would have gotten back 3.632 milliliters. Perfectly fine answer. I was just being lazy and chose not to put anything into my calculator. So it's really up to you. Both the answers are the same and it doesn't matter what format you put it in, as long as it's right. So let's take a look here. We have about 6 left, so we're going to do that. 30 gallons is equal to how many liters? I want you to go to liters here. So we're going to go purple because we need page 26. So page 26, we did this one before. And we're going to use volume. So it's going to be for every 1 gallon. Let's get this out of the way. For every 1 gallon, there's 3.79 liters. All right. So we'll say 30, and the abbreviation for gallon is GAL. Gallon to liters. Gallon cancels with gallon. For every 1 gallon, there's 3.79 liters. So 30, so we would say 30 times 3.79, and that's 113.7 liters. All right. Let's double check everything, make sure everything looks good. So gallons, 3.79 liters. So 30 times 3.79, yep, looks good. So on to the next one. We have 100 yards to a certain number of meters. So we need to go to our table. We need to go to our page 26. And let's see what we have. So we need to go to length, yards to meters. We actually have one. For every 1 yard, there is 0.91 meters. So we are going to say 100 yards. Do your little table here. Yard and then meter. For every 1 yard, there's 1 meters. Multiply across the top. So 100 times 0.91, and you should get 91 meters. Again, yards and yards cancel, leaving you with the unit of meters, so 91 meters. just a few more problems to go. Hopefully all your doubts clearing up. If you still have questions after watching this video, please send me an email, or think of some questions that you have, and we can talk about it on Tuesday during the lab. So let's keep powering through this. Almost done. So just a few more problems left. Degrees Fahrenheit. So 72 degrees Fahrenheit to Celsius. Degrees Celsius. So we're going to go to page 26 again. And there's my purple. Page 26. So we need to use a different formula this time. Degrees Celsius is equal to 5/9 times degrees Fahrenheit minus 32. Okay. Let me double check my formula. Everything looks good. 5/9. Okay. So, PEMDAS again. Please excuse my dear Aunt Sally. We're going to multiply, and we're going to do parentheses first. Parentheses first and then multiply. So degrees Celsius is equal to 5/9 times, and let's do what's in those. We're going to say 72 minus 32. So 5/9 times 72 minus 32 is 40. So 5/9 times 40 is 22.2 degrees Celsius. And there's your answer. All right, clear up, and let's look at the next one. The next problem is 15 nanometers to meters. So this one's just be a one-step conversion because you're going from nanometers to your base unit. So nanometers, and then nanometers on the bottom, meters on the top. Okay, so there is 10 to the 9 nano. Oh, I'm all messed up here. Let's get this cleaned up. Nanometers in 1 meter, or 10 to the -9 meters in 1 nanometers. These are the same. Again, I hope that you've gotten, I think I've written this for every single one. Hopefully you're making the connections. If you're going to use the negative, it has to go with the base unit. If you're not, if you don't want to, if you are confused, stick with the way I originally taught it. But I'm going to stick with doing it this way. And saying meters is larger, so I'm going to put 1 there. And nano is 9, so 10 to the 9th. So this is 15 times 10 to the -9 nanometers. So I'm going to put this in my calculator. 15 times, actually, let's rewind. I'm being lazy, so let's convert this. I was just going to do it without putting it into my calculator. Let's do this. Put this into your calculator. Say 15 divided by 10 to the 9th. And you should get 1.5 times 10 to the -8 meters. Okay, so this is what you're going to get. I didn't want to confuse you, but I do want to show you scientific notation again because it's so important. You could have done this problem without plugging it into your calculator, and that's what I was going to do. And for those of you who are interested in learning it, I just deleted it. So let's go back. There it is. Let's look at this. And let me see if I can get rid of just this part here. Here's my answer, and this is what the calculator is going to spit back to you. Just to recap for a second, nanometers and nanometers cancels, leaving you with a unit of meters. All right. So here we are, unit of meters. Now let's do this math without using our calculator. So let's review that scientific notation for a second. Let's delete this off. Okay. Okay, so see this -9's on the bottom, we're dividing. So when you bring it to the top, when you're dividing, you essentially make it negative. So this will be 15 times 10 to the minus 9 meters, right? We can't leave it like that. So we're going to do 1 this way, so you add 1 here. And that's 1.5 times 10 to the minus 8 meters, same thing we had before. So if you're interested in the scientific notation, there's the logistics of it. If not, just plug it into your calculator like I did previously. Let's delete this and go to the next one. Just a couple more left. All right, so this is another temperature problem. And let's get back to the black ink. So you have negative 13 degrees Celsius, and we're converting that to Fahrenheit. Let's go to page 26 and get that formula. So degrees Fahrenheit is equal to degrees Celsius times 9/5 plus 32. Please remember your order of operations, right? So you're going to do, so please excuse my dear Aunt Sally. You're going to do the multiplication before you do the addition. So degrees Fahrenheit is equal to negative 13 times 9/5 plus 32. So let's do this part first. Negative 13 times 9/5. And that is negative 23.4. And then plus 32. .6 degrees Fahrenheit. There you go. And well, the very last problem we're going to look at here is 25 micrograms to ounces. Oh boy, we're going to need page 26 for this because we're using one of our standard units, a nanometrics unit. So let's take a look. We're going to go to volume, fluid ounce. For every 1 ounce is equal oh, sorry, it didn't say fluid ounce, did it? It just said regular ounce. So there's a difference here. You can weigh things in ounces, right? Or you can weigh fluid ounces, which is if you're thinking about a volume, then it'd be a fluid ounce. But if it's a pound, if it's a weight or a mass, you're looking at just a standard ounce. So at first I misread this. So we're looking here at a mass, okay? So if we're looking at a mass, we're still on page 26, and we're going to be doing for every 1, oh, my marker's not wanting to work. Here we go. 1 ounce is equal to 28.3 grams. All right, there we go. Straight from page 26, I would give you this information if we needed it on an exam. All right, so here we go. Now, we need a plan because notice that says to grams, and 1 ounce is equal to 28.3 grams. What I want to do first is set up a plan, and my plan is going to be to go from micrograms to grams. If I can get my answer in grams, then I can use this, right? So we're going to go from, and then we'll go from grams to ounces. So it's a 2-step problem. All right, so 25 micrograms. And we're going to convert that to grams. Micrograms goes on the bottom, grams is on the top. And again, here you're going to say if you're 10 to the 6 micrograms is equal to 1 gram, or 10 to the negative 6 grams is equal to 1 microgram. It's up to you. Okay, so that's going to put that into your calculator. You could use your knowledge on scientific notation if you'd like to answer this without putting it into your scientific notation and without putting it into your calculator. But you're going to do 25 divided by 10 to the 6. And that should give you 2.5 times 10 to the negative 5 grams. So that's we're going from here, micrograms to grams. And now let's do the second part. So we're going to do 2.5 times 10 to the minus 5 grams. And we're now able to use the information that we got from page 26. We know that there is 28.3 grams in 1 ounce. And I'm going to clean this up just a little bit so I can have room to write my answer. So we're going to say 22.5 times 10 to the negative 5th divided by 28.3. And that gives us 8.8 times 10 to the negative 7 ounces. And I'm going to write it down here just so you can see it again. 8.8. That didn't help. In an attempt to make it clearer, I think I made it look even worse. So I'm not sure how much you guys are hearing of my child in the background, but I do apologize. Life of a 4-year-old running around. 8.8 times 10 to the minus 7 ounces. And there you go. Final answer here. So I really hope that going through all of these problems helped. If you're still having trouble, please come and see me. I really think it's important that you understand this math, especially if you intend on taking higher level maths, especially chemistry. It's fundamental chemistry stuff where you're going to be really powering through this in chemistry and you're not going to get as much time to work on it. So please go through it. And hopefully this helped. If you still have questions, please bring those to class on Tuesday so we can go over them. All right, thanks. Thanks for watching. Bye.